Lab Techniques Part 1, Recrystallization for HSC students. So what is recrystallization? So it's basically a purification method whereby a solute compound is dissolved into a solvent, which is then cooled slowly to form pure crystals of this compound. So we want to get these crystals. Now we need to understand solubility before we understand how and why recrystallization works. So solubility is how readily a substance, the solute, can dissolve in another, the solvent. Now solubility is affected by temperature. As temperature increases, more of the solute can be dissolved in the solvent as there is more energy in the system for these bonds between these compounds and even the impurities to break apart. We see this relationship in the bottom right graph. As temperature on the x-axis increases, more grams of solute per 100 grams of water can be dissolved. This is the same in the opposite direction. As there is less temperature, there is less energy, and therefore less of the solute can be dissolved in the solvent. Just think of tea and cold water. More sugar will dissolve in tea than it will in cold water. What's a solubility limit? It's basically the point at which no more of a solute can be dissolved in a solvent at a specific temperature. Now every compound has a different and unique solubility limit, and this difference between each compound is what recrystallization is based off. So recrystallization or precipitation can only occur once the solubility limit has been exceeded. This is in saturated solution. How do we recrystallize a compound? First, we need to boil the solvent and the solute. We can use a steam bath. After this, we must dissolve the solute in the minimum amount of solvent to achieve a saturated solution, which is necessary for recrystallization to occur. Next, we let the solution rest at room temperature and finally place it in an ice bath. The longer we leave the solution to rest, the more crystals will form and the more accurate our experiment will be. Now, when do we use recrystallization? When we know that there are impurities in our crude solution, and when we know that these impurities have solubility limits that vary greatly from our compound of interest. We should also only use recrystallization as the final step after isolating and extracting the compound of interest. For example, we can use recrystallization to isolate benzyl from ethanol or to isolate benzoic acid from boiling water. We use these properties of solubility and our understanding of solubility limits and the differentials between impurities and the compound of interest in order to achieve a purified sample. Little joke, if you're not part of the solution, you're part of the precipitate. Very funny. Thank you.